Hello everyone. So in this video, we'll learn a different topic, slightly different from the previous ones, regarding a system of differential equation. So we'll first see how a system of first order differential equation looks like. System of first order differential equation. So here is an example: x1 prime equal to 3x1 plus 3x2, x2 prime equal to 5x1 plus x2. So you can see this is a system, and this is said to be coupled system because you can separately solve x1 and x2 because the differential equation involving x1 prime contains x2 term, so you can't solve individually x1 and x2. So it's called a coupled system of differential equation. Okay. An usual problem in this section of system of differential equation is to convert a nth order differential equation into a system of first order differential equation. So suppose you have a nth order differential equation c1 yn. This bracket n means n times derivative plus c2 yn minus 1 plus c1 y plus c0 equal to 0. Suppose we have this nth order differential equation homogeneous. Then let us see how we'll convert into a system of first order differential equation. So we assume x1 as y, x2 as y prime, x3 as y double prime, so on up to xn minus 1, xn as y n minus 1. So once we have this, then we differentiate each of the term. x1 prime equal to y prime, but y prime is x2. x2 prime is y double prime, but this is your x3. So on up to xn prime is yn. That we will see how to write. But before that, let us do one more step. X n minus 1 prime. This is y n minus 1. This is xn. So now this yn that we will get from this equation. So here, of course, this c1 is not equal to 0. Otherwise, it is not a nth order differential equation. Now you can move this whole remaining part to the other side of the equation and divide it by c1. So that will replace this y. So now you can see that it is a system of n first order differential equation. So this was a general case. Now let us see for a particular example how to convert a higher order differential equation into system of first order differential equation. So suppose 4y double prime minus 3y prime plus 5y equal to 0. This is our second order homogeneous differential equation. We want to convert it into a system of first order differential equation. So x1 equal to y, x2 equal to y prime. From this differentiating, we have x1 prime equal to y prime. That is nothing but x2. x2 prime is y double prime. So that we will get from here. So what we get is 3y prime minus 5y divided by 4. So 3 by 4 y prime minus 5 by 4y. So now I have to replace y prime by x2. So 3 by 4 x2 minus 5 by 4 x1. So hence the required system is x1 prime equal to x2, x2 prime equal to minus 5 by 4 x1 plus 3 by 4 x2. So this is our required system. Okay. Now let us see how to solve system of first order differential equation. So for that we will take our example, first example, that is x1 prime equal to 3 x1 x2 plus 3 x2 and x2 prime equal to 5 x1 plus x2. So we can convert this system into a matrix. So let's see how to convert it. So here you can write x1 x2 prime plus 3 3 5 1 x1 x2. So if you take this as capital X, this as A, then we have x prime equal to X. This is the matrix form of the system of differential equation. So now using the eigenvalues and eigenvectors of the matrix A, we will give the solution of the system. So determinant of A minus lambda I. Let's find the eigenvalues first. So it's 3 minus lambda, 1 minus lambda minus 15 equal to 0. So I can calculate. I'm not doing the whole thing. So here you can check the 6 and minus 2 with the eigenvalues. Also A times 1, 1 gives this thing, and the eigenvector corresponding to minus 2 is minus 3, 5. So the general solution of the system is given by x of t, that is nothing but x1t and x2t. This is c1 e power 6t 1 1 plus c2 e power minus 2t minus 3. So this is how we solve system. So let's just quickly recall what we did today. So we saw how does a system of first order differential equation look like. Then from a general nth order differential equation, we converted it into a system of n first order differential equation. We saw an example how to do that with a second order differential equation. This thing. This was our obtained system of first order differential equation. And we also saw how to solve a system of first order equation using eigenvectors. Eigenvectors of the matrix form of the differential equation.